Let's look at the following. 7/8 plus 3/20. Are they speaking the same language? Meaning, do they have a common denominator? No, they don't, which means we cannot add these two fractions. Since they're not speaking the same language, we need to bring in translators. But before we can do that, we need to identify what is their common language, which means we need to find the least common multiple, so you need to take the time now to do the chart. From the chart, you should have identified that the least common multiple would be 40. So now that we've identified their common language, let's see what the translators are going to be. The first fraction has a denominator of 8, but we need it to be a 40. So 8 times what gives us 40? 5. So if we multiply 5 in the denominator, we must also do it in the numerator. And so we see 7 times 5 is really 35. And we just created an equivalent fraction. Now we look at the second fraction. It currently has a denominator of 20, but we need it to be a 40. So 20 times what gives us 40? 2. Now if you multiply 2 in the bottom, you must also do it in the top. And so 3 times 2 is 6. Now our fractions are speaking the same language, so now we can add. And remember, when you're adding fractions, you keep the common denominator, and now you can add your numerators. 35 plus 6 is 41. And so that is your simplified answer. Example 1. Add or subtract, simplify if possible. For A, we have 8 over 15 minus 1 over 4. Are they speaking the same language? Again, I'm referring to, do they have a common denominator? And in this case, they do not. So they need translators to help them speak the same language. Now before we bring the translators in, we need to identify what is going to be their common language. To do that, you need to use the chart now. From the chart, hopefully you found 15 and 4 to have a common multiple of 60. So now we're ready to create equivalent fractions. The first fraction has a denominator of 15, but we need it to be a 60. So 15 times what gives us 60? 4. If we multiply 4 in the bottom, we must also do it to the top to help maintain its value. So now we have 8 times 4, which gives us 32. So our new equivalent fraction is now 32 over 60. Our second fraction has a denominator of 4, but we need it to be a 60. Well, 4 times 15 would give us 60. So now we need to do 1 times 15, which in this case gives us 15 for our new numerator. Now we have the fractions speaking the same language, so now we can do the subtraction. Anytime you're adding or subtracting common denominators, you keep the common denominator, and now you can perform the operation of subtraction. 32 minus 15 is 17. Now the direction says to simplify if possible. Notice 17 is a prime number and 17 is not a factor of 60, so this fraction cannot reduce, and that would be your final answer. Example B, 5 over 6 plus 1 over 8. Do they have the same common denominator? No, which means we need to bring in translators. Before we bring in the translators, we need to identify the common denominator, or the least common multiple. If you do not know it as of now, take a moment now to use the chart to help you identify the LCM. Hopefully you found the LCM to be 24. And so now we are ready to write our equivalent fractions. 6 times what would give us 24? Well, that would be 4. What you do to the bottom, you must do to the top. So 5 times 4 is 20. Now our second fraction has a denominator of 8, but we need it to be 24, and that would give us 3. So 8 times 3 gives us 24, which means 1 times 3 would give us 3. Now that our fractions have a common denominator, we're ready to add these two fractions. We keep the common denominator, and 20 plus 3 is 23. Now notice 23 is also a prime number, and 23 is not a factor of 24, so this fraction cannot reduce.